Welcome to today's ArXiv CS Digest for May 21st, 2026. We received 869 new computer science papers today across 57 subfields. Let's dive into the top picks. Trend 1 of 10, Embodied AI Navigation and Control. This trend explores AI systems enabling embodied agents to intelligently perceive, navigate, and control their actions in dynamic environments. This cluster covers 72 papers. Representative work includes AwareVLN, reasoning with self-awareness for vision-language navigation. Remember to be curious. Episodic context and persistent worlds for 3D exploration, and Sensor-to-Sensor, cross-embodiment sensor conversion for autonomous driving. Trend 2 of 10, System Anomaly Detection and Security. This trend unifies research on detecting anomalies and enhancing security across diverse systems, from software behaviors to cyber-physical infrastructure. This cluster covers 61 papers. Representative work includes FAME, Failure-Aware Mixture of Experts for Message-Level Log Anomaly Detection, cyber-physical anomaly detection in IoT-enabled smart grids using machine learning and meta-heuristic feature optimization, and HarnessAPI, a skill-first framework for unified streaming APIs and MCP tools. Trend 3 of 10, Motion-Aware Video Understanding. This trend unifies research that explicitly leverages diverse motion cues for advanced video understanding, analysis, and generation. This cluster covers 125 papers. Representative work includes Which Way Did It Move? Diagnosing and Overcoming Directional Motion Blindness in Video LMS, Cambrian-P, Pose-Grounded Video Understanding, and MotiMotion, Motion-Controlled Video Generation with Visual Reasoning. Trend 4 of 10, Foundations of Algorithms and Computing. This trend explores the mathematical and algorithmic foundations of computation, spanning complexity, optimization, AI, and novel paradigms. This cluster covers 81 papers. Representative work includes tokenization via Convex relaxations, optimal testing of Reed-Muller codes with an online adversary, and on the parameterized complexity of min-sum radii. Trend 5 of 10, Theoretical Machine Learning and Models. This trend develops theoretical foundations, novel models, and advanced inference techniques for deep and probabilistic machine learning. This cluster covers 88 papers. Representative work includes integrable elasticity via neural demand potentials, large-scale score-based variational posterior inference for Bayesian deep neural networks, and the matching principle, a geometric theory of loss functions for nuisance-robust representation learning. Trend 6 of 10, Applied Reinforcement Learning and Privacy. This trend focuses on developing robust, secure, and responsible AI systems, spanning advanced reinforcement learning, privacy-preserving techniques, and model trustworthiness. This cluster covers 104 papers. Representative work includes vector policy optimization, training for diversity improves test time search, corruption-tolerant asynchronous Q-learning with near-optimal rates, and AI-driven multi-region provisioning for cloud services using spot fleets. Trend 7 of 10, Neural Architectures and Data Generation. This trend advances neural architectures and data generation techniques for enhanced model capabilities and data solutions across diverse applications. This cluster covers 81 papers. Representative work includes Gated DeltaNet 2, Decoupling Erase and Write in Linear Attention, DECQ, Detail Condensing Queries for Enhanced Reconstruction and Generation and Representation Autoencoders, and Synthetic Data Alone is Enough. Rethinking Data Scarcity in Pediatric Rare Disease Recognition. Trend 8 of 10, Applied AI for Social Impact. Leveraging AI to tackle diverse real-world problems for significant societal benefit across various domains. This cluster covers 83 papers. Representative work includes GesVLA, a benchmark for geospatial question answering, Symphony for speech-to-text, supporting real-time medical voice interfaces, and evaluating commercial AI chatbots as news intermediaries. Trend 9 of 10, Self-Evolving Multi-Agent Systems. This trend explores multi-agent AI systems that autonomously learn, adapt, and improve their own behaviors and performance. This cluster covers 73 papers. Representative work includes MOS, Self-Evolution through Source-Level Rewriting in Autonomous Agent Systems, LC-Guard, Latent Communication Guard for safe KV sharing in multi-agent systems, and DeltaBox, scaling stateful AI agents with millisecond-level sandbox, checkpoint/rollback. Trend 10 of 10. LLM architectures and training. This trend focuses on advancing LLM architectures, optimizing training, and enhancing their efficiency, interpretability, and practical application. This cluster covers 101 papers. Representative work includes understanding data temporality impact on large language models pre-training, lemur, learned multi-vector retrieval, and beyond LLMs, sparse distributed memory, and neuromorphics, hyperdimensional SRAM-CM, VA-CoAL for ultra-high speed, ultra-low power, and low cost. Up next, our first paper out of 10, Decept Chain, Inducing Deceptive Reasoning in Large Language Models by Wei Shen and Huan Zhang from University of Illinois Urbana-Champaign. Let's break down its key contributions. The authors identify an urgent and underexplored risk where attackers can induce large language models to generate incorrect yet coherent chains of thought, which appear plausible to humans. This contribution highlights a significant vulnerability in current LLM reasoning. The authors introduce Decept Chain, a novel backdoor attack paradigm specifically designed to steer LLMs into producing reasoning that looks benign while ultimately leading to incorrect conclusions. This system focuses on creating stealthy and deceptive reasoning processes. This contribution details Decept Chain's sophisticated methodology, which exploits LLM hallucination by fine-tuning on naturally erroneous rollouts, and then reinforces this behavior using group relative policy optimization with a flipped reward. The system also leverages a plausibility regularizer to maintain fluent and benign-looking reasoning. The system achieves high attack success rates across multiple benchmarks and models, with minimal impact on benign scenarios. Moreover, a careful human evaluation showed that human raters struggle to distinguish the manipulated reasoning from benign ones, underscoring the attack stealthiness. Up next, our second paper out of 10, Semantic Attacks on Tool-Augmented LLMs, Securing the Model Context Protocol Against Descriptor-Level Manipulation by Saeed Jamshidi and Fotse Combe from SWAT Laboratory, Pollitt. Let's break down its key contributions. The authors introduce a detailed taxonomy of 3 novel semantic attacks specifically targeting the Model Context Protocol in tool-augmented LLMs. This contribution focuses on explaining how threats like tool poisoning, shadowing, and rug pulls exploit vulnerabilities embedded within tool descriptors. The system introduces a comprehensive, layered security framework specifically designed to counter the identified semantic threats. This framework leverages RSA-based manifest signing for integrity, LLM-on-LLM semantic vetting for detection, and lightweight heuristic guardrails for runtime protection. This contribution focuses on evaluating the proposed framework's effectiveness and the varying resilience of different LLM architectures, including GPT-4, DeepSeek, and Llama 3.5, against semantic attacks. The authors find that security performance varies widely across models, with GPT-4 demonstrating a strong balance between safety and latency. Up next, our third paper out of 10, General Agentic Planning Through Simulative Reasoning with World Models by Minkai Deng and Eric P. Xing from Carnegie Mellon University. Let's break down its key contributions. The authors introduce SIMU-RA, a novel, goal-oriented architecture designed for generalized agentic reasoning. This system aims to overcome the limitations of current one-task, one-agent approaches by providing a principled formulation for optimal agent behavior. This contribution focuses on addressing the challenges of black-box autoregressive reasoning by incorporating a world model for planning via simulation. SIMU-RA explicitly simulates action consequences, mirroring human cognitive processes for more robust decision-making. The system leverages large language models, LLMs, as a flexible substrate for its prototype world model. This implementation uses natural language for discrete, hierarchical representations, making the approach model-agnostic and adaptable for planning. The authors demonstrate significant performance improvements, with SIMU-RA boosting success rates on complex web browsing tasks from 0% to 32.2%. Across various tasks, world model-based planning achieves up to 124% higher completion rates compared to black box autoregressive baselines. Up next, our fourth paper out of 10, Enhancing Causal Reasoning in Large Language Models, a causal attribution model for precision fine-tuning by Hung-Rui Kai and Rui Song from University of California, Irvine. Let's break down its key contributions. The authors introduce a novel causal attribution model that employs do-operators to construct counterfactual scenarios. This allows them to systematically quantify how input numerical data and an LLM's pre-existing knowledge influence its causal reasoning processes. This contribution focuses on a newly developed experimental setup designed to rigorously assess large language models' reliance on both contextual information and their inherent knowledge across diverse domains. The evaluation reveals that a large language model's causal reasoning ability primarily depends on the specific context and domain-specific knowledge provided to it. Even without explicit knowledge, LLMs can still perform some causal reasoning using numerical data, though with certain limitations. The system leverages the insights gained to propose a fine-tuned large language model specifically designed for pairwise causal discovery. This model effectively combines both knowledge and numerical information to enhance its performance. Up next, our fifth paper out of 10. Is capability a liability? More capable language models make worse forecasts when it matters most by models make worse forecasts when it matters most, and Ezra Carter from Nick Merrill. Let's break down its key contributions. The authors document a significant inverse scaling phenomenon where more capable language models actually produce worse distributional forecasts, especially for time series with superlinear growth. And up next, our sixth paper out of 10, compiling agentic workflows into LLM weights. Near frontier quality at 2 orders of magnitude, less cost by Simon Dennis, and Hao Guo from University of Melbourne. Let's break down its key contributions. The authors introduce a novel approach called subterranean agents, which involves compiling complex procedural workflows directly into the weights of a small, fine-tuned language model. This method aims to resolve issues like context, window consumption, and proprietary data exposure often associated with external orchestration frameworks. This contribution focuses on identifying and empirically addressing 3 key perceived barriers that have historically limited the adoption of subterranean agents among developers. The authors aim to demonstrate how these challenges can be overcome, encouraging broader use of this efficient architecture. The system leverages extensive empirical validation across a diverse set of real-world procedural tasks, including travel booking, Zoom support with product-specific knowledge, and complex insurance claims. This rigorous testing showcases the practical applicability and robustness of their subterranean agent approach. Up next, our 7th paper out of 10, No Epic Like the Present. Robust climate emulation requires out-of-distribution generalization by Bradley Stanley Clamp and Ingmar Posner from University of Oxford. Let's break down its key contributions. The authors confirm that climate emulation is fundamentally an out-of-distribution projection task, highlighting how climate change leads to significant and progressively growing shifts in atmospheric state distributions, which current ML methods struggle with. This contribution empirically establishes that seasonal variation serves as an effective proxy for long-term climate shifts, providing access to real-world distribution shifts without needing synthetic perturbations. The authors introduce a novel evaluation framework that leverages these seasonal shifts as a rigorous, zero-overhead testbed for assessing emulator robustness. Their systematic characterization confirms that current state-of-the-art hybrid ML emulators degrade significantly when faced with these realistic seasonal shifts. The authors chart a path forward by identifying compositional generalization, specifically through physically motivated decompositions, as a principled route towards robust climate emulation, showing improved out-of-distribution performance. Up next, our 8th paper out of 10. Check your LLM's secret dictionary. 5 lines of code reveal what your LLM learned, including what it shouldn't have, by Hisashi Miyashita from Ignite Incorporated. Let's break down its key contributions. The authors introduce a groundbreaking method that uses singular value decomposition of an LLM's LM_head weight matrix. This technique, requiring only 5 lines of PyTorch code and no model inference, effectively reveals interpretable semantic subspaces directly from the model's weights. This contribution focuses on a systematic analysis of various LLMs, including GPT, Gemma, and Qwen, using the SVD method. The researchers found that singular value spectra and vocabulary cluster structures differ significantly across models, revealing insights into their training data and even identifying ethically inappropriate subspaces originating in pre-training. The system leverages 2 new metrics, the Vocabulary Cluster Score, VCS, to quantify subspace coherence, and the Weighted Projection Score, WPS, for static glitch token detection. Applying WPS to GPT OSS, 120B successfully recovered a well-known glitch token, demonstrating its practical utility without needing model inference. The authors propose that LM_head SVD analysis should be adopted as a standard pre-release safety auditing step for large language models. Their findings also suggest exciting new directions for SVD-guided tokenizer optimization and the design of more controllable LLMs. Up next, our 9th paper out of 10, Hallucination as Commitment Failure. Larger LLMs misfire despite knowing the answer, by Juin Yom and Tae-Sup Kim from Graduate School of Data Science, Seoul National University. Let's break down its key contributions. The authors introduce a novel semantic notion of answer availability, challenging the traditional view that hallucinations are solely due to missing knowledge. This new perspective considers whether the correct concept is present when the model commits to an answer. This contribution reveals that a substantial percentage of instruct hallucinations, particularly in larger models, occur even when the correct concept already holds significant probability mass. The rate of these commitment failures consistently increases with model scale. The authors find that the key differentiator between correct generations and hallucinations is not the presence of the correct concept, but how its probability is distributed. Correct responses concentrate mass on a single form, while hallucinations disperse it across alternatives. This contribution identifies a single mechanism where instruction tuning sharpens answer commitment with scale. This sharpening leads to both increased helpfulness and the phenomenon of confident hallucination. Up next, our 10th paper out of 10, Planning in the LLM Era, Building for Reliability and Efficiency, by Michael Katz and Shirin Sarabi from IBM Research. Let's break down its key contributions. The authors highlight the inherent limitations of initial LLM-based planning methods, noting their unsound and incomplete nature. This contribution points out how these early attempts often consumed substantial resources without delivering better solutions for new problems. This contribution focuses on a significant shift in how large language models are used for planning, moving towards generating symbolic solvers. The system leverages LLMs to create verifiable and efficient solvers that can be used effectively at inference time. The authors emphasize that the new trend in planning directly addresses the growing need for agents that are both reliable and resource efficient. This approach offers a clear path towards creating maintainable planners with reduced reliance on large language models during inference. The authors examine 3 major categories of planner generation methods, discussing their current limitations. This contribution outlines crucial research steps needed to achieve more reliable and efficient LLM-based planner generation. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.